Now we'll talk about hazardous waste management. Now the first of these is making a hazardous waste determination. Certainly you want to accumulate hazardous waste properly and dispose of it through EH&S. The first of these, the hazardous waste determination, is one of the points that EPA focused on in their changes. We already have to make a waste determination in that we're going to label things as hazardous waste and dispose of them properly, but they indicated that the hazardous waste determination needs to come from the generator, which is really you. You have the most depth of knowledge about the particular waste that you're generating, so it's appropriate for you to make that waste determination. Now, we'll talk about how that applies in different situations, but generally you're doing this already. If you have a waste bottle of solvent, you collect it in an amber 4-liter bottle, you put a label on it, you list the description of the contents, that's a hazardous waste determination. You've decided that it's waste based on those properties that we may have covered in previous trainings that you understand about that waste. That is a hazardous waste determination. Sometimes it's not so straightforward, but that's the process we're talking about. How do we do that? The EPA has different definitions of hazardous waste, and we'll talk about those different things, but essentially it's either an EPA listed waste, or it's an EPA characteristic waste, or another category that we encounter here on campus that doesn't fit into those two definitions, but still should be managed appropriately, is something that we know to be particularly harmful to humans or the environment, and want to collect also as hazardous waste. And we'll talk about some examples. We'll talk about how some things don't meet that EPA definition. So you're going to ask yourself one of these three questions. Is it listed waste? Is it a characteristic waste? Or do I know it from SDS knowledge or from other information? Do I know it to be particularly harmful? Not everything is going to fit into this category. There's a lot of things that are irritants but are not hazardous waste and don't require management as hazardous waste. We're looking for these things that are particularly harmful. But again, waste determinations need to be made at the point of generation. That means in the lab at your SA or where you generate the waste. The lists were generated when the EPA first came out with the hazardous waste rules. The P and U lists are specific commercial chemical products that the EPA decided at the time were particularly harmful, and because at times they were discarded, unused, they became automatically hazardous waste just because of the properties that were identified. If you have these on your shelf, it doesn't mean they're hazardous waste already, but when you dispose of that material, it becomes hazardous waste because it qualifies as a listed waste. And that applies to the P and U. Now the P listed waste were designated as acutely hazardous waste. Those materials have some additional management requirements, and we'll talk a little bit about those, but one of those is any P listed waste or P listed container, if you used it up and there's still some residue in there, that container has to be triple rinsed. You have to collect the rinsate, but those containers have to be triple rinsed before you can get rid of the container. We're also limited to 1 kilogram, roughly 1 quart or 2.2 pounds of P-listed waste in your satellite accumulation area. Doesn't happen very often, but there is that limit. F-listed wastes are wastes that are generated after they're spent. And for simplification of the process, there are a lot of different specific F-listed wastes. A lot of them have to do with specific processes or how they're generated. In our case, the F-listed wastes that we need to be considering are solvent waste. So you've got products that are on a list, and you can find these lists on the EH&S website. There's a link to what the P and U listed materials are. There's about 850 chemicals that are specifically listed. And then the F list, to simplify it, essentially all your solvent waste is going to become listed waste as well. You've got these three lists, and what actually becomes listed waste. Now you've got product, as I mentioned, for the P and U materials, and then you've got spent solvents, which would become waste when we decide to get rid of them. So if you've got a process that, or let's say you have a P-listed material that's been diluted. You dilute something down to a particular product strength and you add it to your solution for whatever reason. The dilution is still the P-listed material. Unused, it still qualifies as hazardous waste when you get rid of it. So if you have old stock solutions, they're going to become hazardous waste, or old product. You finish with your project, you're cleaning out your lab, those become hazardous waste because they're on the list. Now, F-listed, once it's spent, that becomes hazardous waste when you dispose of it. So you've run your process, this spent solvent waste or mixture becomes hazardous waste when you get rid of it. The other part is if you mix these listed materials with anything else for disposal. I've spilled my P-listed or U-listed material. I clean it up, that whole mixture becomes listed waste. I contaminate something with my spent solvent, that whole mixture becomes hazardous waste. So listed wastes are either by product, processed spent solvents, or mixtures, including spills or things that absorbed or contaminated with those materials. Now, beyond the list, because there's only so many chemicals that are listed and only includes spent solvents or those mixtures, EPA added characteristics to capture a lot of other things that might become hazardous waste. So you've got 4 characteristics: ignitability, corrosivity, reactivity, and then toxicity. The specifics of which we'll talk about coming up. Ignitability or flammability is the first characteristic, and it applies to liquids most easily because it depends on a specific flash point. So if your product has a flash point of less than 140, your waste may take on that characteristic hazard as well. And depending on concentration and the flammability of what you've mixed it with, or the flammability of the original product, it's likely to become a flammable hazardous waste. And I'll tell you from experience that even low concentrations of alcohols become, as let's say, a low concentration in an otherwise aqueous mixture, still flash below 140. Methanol has a flash point of 53 degrees, mixed with 95% other water, still flashes below 140. So as a rule, if you start with a flammable product or a product that meets that standard, you're going to wind up with a flammable hazardous waste. So once again, you're looking at the product, you think about the process, and which leads to your waste determination. So characteristic 1 is the flammability or ignitability. It also includes solids, also gases. A lot of people overlook aerosol cans. Aerosol cans commonly contain flammable propellant or flammable carrier. Nearly every aerosol can that we're going to dispose of is going to qualify as a flammable or ignitable waste. The key is to either empty that completely, which is a challenge, but recognize it as such and collect it for disposal. A lot of the products you use at home you might have in the lab as a solvent or a lubricant. At home, there's no regulation. Here there is. So everything here is regulated, so we have to account for it. It's a common practice of inspectors to look in the garbage cans, to look in the trash, to look in dumpsters for our mistakes. So make sure that you're considering all things that might be ignitable. Ignitable also includes oxidizers. So if you have solid or liquid oxidizer, concentrated oxidizers, they're going to qualify because they'll provide oxygen or further chemical combustion. Next characteristic is corrosivity. The corrosive characteristic applies only to liquids. Corrosive liquids with a pH of less than 2 or greater than 12.5, greater than or equal to 12.5 or less than or equal to 2, those extremes are considered corrosive hazardous waste. So you may start with a product, strong acid, concentrated acid, certainly going to meet that standard. Your process may neutralize that. It may dilute that. The pH scales takes a while to dilute these things, but in the end, you're really going to measure the pH of the product, the waste, what you're getting rid of. But it is wise to consider the source product and the process, and then you'll make that waste determination based on all that information. So strong acids, inorganic acids typically are the strongest. There are some stronger organic acids to be considered: trifluoroacetic, acetic acid, trichloroacetic. Bases, organic bases, you're not going to be able to take a pH of an organic base, but because of what you understand about it, amines, diamines, those are all going to be strong bases. When they're mixed with water or maybe even exposure to moisture in the air, they're going to have that corrosive impact. So high pH, low pH. Curiously, it applies to liquids. Solid corrosives, such as sodium hydroxide pellets, are one of those things that are in that last category. Not defined specifically by the EPA's hazardous waste, but we know it to be harmful, and we don't want to toss that in the regular trash. The next characteristic is reactivity. Reactivity refers to the inherent quality of that material or chemical to react with water or air, or to react to release a particular toxic or flammable gas. Cyanides and sulfides are specifically defined as reactive materials by the EPA. Things that are described as reacting violently with water. You might see that blue label on a product, dangerous when wet. Reacts violently with water, not just reacts with water and decomposes or reacts with water and degrades, but reacts violently with water would qualify as reactive, has an obvious hazard, and certainly is going to become a hazardous waste when disposed of. Now again, think about your product. And your process may involve quenching that. It may react, you may purposefully react small amounts of this in your process, and it may quench that reactive material or counter that cyanide or react out the sulfide. Think about your product, what the process involves, and what is the condition of that final waste. This is that waste determination process that the EPA wants us to focus on. Certainly, things that are capable of detonation would also qualify as reactive material. The last characteristic is toxicity. And toxicity is a little more complicated, but it refers to the waste exhibiting the characteristic toxicity of a particular compound. There's a list of 8 heavy metals, 10 less commonly used pesticides, but sometimes they're still used in research or encountered in research as standards, and 20 very common organic chemicals, including some stuff you're going to use probably on a regular basis: chloroform, benzene, pyridine. Cresol is more common than you think as a preservative. Cresol is actually in some insulin products. So oddly enough, the same product, and they've actually backed down the concentrations, but previously the concentration in an insulin product that would be normally injected would actually qualify as hazardous waste. So Cresol, and there are different forms of it, but Cresols, pyridine, very common organic chemicals are going to wind up on this list. Now, you have these list of particular compounds, and your waste would exhibit the characteristic of toxicity for that material if it meets a certain numerical threshold. And that would be determined by specific testing, or we know the concentration in the waste, so we know whether or not it meets that standard. So for these materials, if they're in your starting product, the thresholds are at parts per million and sometimes lower for some compounds. For mercury, it's 0.2 parts per million. At that level, you're almost always going to meet the standard. Parts per million is 1/10,000th of 1%. So if you're working in percents, you're well over that threshold. So if it's in your original starting material, it's going to be considered a hazardous waste because of that characteristic of toxicity. Knowing your product, once again, I'm repeating myself, but know your products. A lot of people miss these items in their products. We'll talk about some products or reagents that are commonly named but they don't use standard chemical nomenclature, so you might miss some of these ingredients. So know your products. You should know it for your own safety, but in order to make a proper waste determination, you need to know what's in the products you use. A lot of times we use kits. There's a whole box set of things. You use reagent A, B, and C. You need to know what's in there. That's going to be your job to make sure that you know what's in the product, so you know what's in the waste and how that process works. You really should understand it anyway. So finally, we encounter these items that don't meet that definition, that don't fall under the lists, that don't exhibit the characteristic of toxicity as defined by the EPA, but are still very harmful. And so our challenge is to identify those things and then collect them and manage those as hazardous waste as well. We don't want to put those in the regular trash because then we're exposing the handlers of that waste to these hazards. If we know it to be hazardous, give it to EH&S for disposal. We're going to manage that as hazardous waste. Another addition recently to the EPA's set of rules was a limitation on drain disposal. The EPA definition for corrosive waste is less than or equal to 2 or greater than 12.5. Well, for industrial, even to sanitary sewer discharge of liquid waste, if it doesn't have another hazardous characteristic, if it's not flammable, if it's not reactive, for any other reason, say you have an aqueous solution that happens to have a pH above 2, but less than 5, is still prohibited from drain disposal. So what do? There's a lot of chemistry between 2 and 5 on the pH scale. Soft drinks, lemon juice. We're not talking about those personal products. Those, you put in a sink in the bathroom. What goes down your sink in the lab can't be less than 5. So what you can do is either collect it for disposal through EH&S, or you can adjust the pH yourself. You're absolutely allowed to adjust the pH yourself. You probably have all sorts of reagents in the lab that you could adjust the pH with. Any hydroxide would easily raise the pH enough to get it beyond 5. Then you can drain dispose of it, as long as it doesn't have any of the other characteristics. Those are our 3 categories: listed, characteristic, and then those items that we know to be harmful that don't fall into those first 2. So we're thinking about a determination. I've said this many, many times here, but think about the product, think about the process, and then ultimately what the resulting material is. And if it happens to be a spill, then it's going to qualify as well.